More problems from section 7.1, some area problems. The first one is going to be problem number 38, area between two trigonometric curves. So our functions are f of x equals sine of x, and g of x is cosine of 2x. And are we given the intervals? Yes, we're given the interval negative pi over 2 is less than or equal to x is less than or equal to pi over 6. Now, can anyone sit here and tell me which one's going to be the top function, which one's going to be the bottom function? Kind of hard. Yeah, we were just looking at it, so that might have helped. But in absence of that, then let's graph it. Let's graph it on your graphing calculator. So if you've got an older one, so let me see. If you got some of the older ones, you can change the style of the graph. Derek, can I borrow yours for a second? Yeah. All right. So let me put in, let's put this in, so you got the first one in. Let me clear out the second one. It's a little dark there. Let's see here. That's better. Okay, so the second one is cosine of 2x. And what I want to do is, if you go to the left here, then you can press the enter key, and that changes the style of the graph so that you know which equation is which when you graph these things. So, nice little trick for you. As far as my window is concerned, I'll go from negative pi over 2 to pi over 6. Now, when you press the enter key, of course, you're going to lose the nice pi symbol. It's going to be replaced by a decimal. That's okay. I think I'll be okay with these limits because sine and cosine go between 1 and negative 1. So let's just hit the graph key, and hopefully we're in radian mode. Looks like we are, otherwise we wouldn't be getting a nice neat graph. But what's nice about this is that it tells me which one's my top function. My top function, the thicker line, is the cosine of 2x. The bottom function is the sine of 2x. And that's really the gist of why I set this up like I did, is so that I knew which one was the top and which one was the bottom function. So we're not even going to bother graphing that one. Let's just try and do this one a little bit quicker then. Area of one rectangle. We're back to being able to take a dx slice. So it's going to be top minus bottom times dx. Top function was the cosine of 2x minus the bottom function, which is the sine of x dx. And over here are my limits of integration. We don't even have to worry about trying to find the point of intersection there. So it's going to be from negative pi over 2 to pi over 6 of the cosine of 2x minus sine of x dx. Now, it's up to you. I mean, once you get comfortable with these things, you kind of be able to do them maybe backwards or something like that, or do this without the u-substitution. But for the first term there, unless you're really good with the antiderivatives, you're going to be kind of stuck having to do a u-substitution. I'm going to split this one up. Negative pi over 2 to pi over 6 cosine of 2x dx minus the integral from negative pi over 2 to pi over 6 of sine of x dx. Now, why did I do that? Well, for the second one, I can find an antiderivative there, right? What's the antiderivative of sine of x? Negative cosine. I'm glad to hear everyone got the negative in there. So this is going to be minus the function negative cosine of x evaluated between negative pi over 2 and pi over 6. If you want, we can cancel that negative. All right, no, I'll just leave it out here. Negative of cosine of pi over 6 minus, oh boy, I think we should have got rid of that negative, right? It's just such a pain. Minus, and then again, you got a negative cosine of pi over 2. Fortunately, if you screw up on that one, it's not going to matter too much. Actually, this should have been a cosine of negative pi over 2. But either way, cosine of pi over 2 or cosine of negative pi over 2 is the same. It's 0. So now we're left with the cosine of pi over 6. If you don't remember it off the top of your head, well, here's kind of a workaround. Make sure your calculator's in radian mode. And then, let's see, we'll do cosine of pi over 6. And I'll get some decimal number which I don't recognize at all. But then hit the square key, and maybe recognize that. If you square it, you get 3/4. If you take the square root of that, you get the square root of 3 over the square root of 4, or better yet, the square root of 3 over 2. So what I have here is really negative square root of 3 over 2. Well, you've got a double negative there. So you'll end up adding the square root of 3 over 2. All right, so that's the allegedly simple side, right? We got to go back and work the other one. The other one's going to require a u-substitution, or at least can be done with a u-substitution. So let's work on that part. Are you okay with the trig one here? This first part here? Well, second part or first part? This part. As far as this one's concerned, in order to get past the fact that this isn't just the cosine of x, we'll do a u-substitution. U equals 2x. du would be 2 dx. So 1/2 du equals dx. And then let's plug in some values like u of pi over 6 or u of negative pi over 2. Let's start with that one. U of negative pi over 2. That means take 2 times negative pi over 2. What'll I get? If I put in, yeah, negative pi. Good. U of pi over 6. Pi over 3. All right, so we're going to make our u substitution, and we're not going to look back. We're not going to go back and change this into terms of x. So the integral between negative pi and pi over 3 of cosine of u times 1/2 du. Now the 1/2 can come out in front. So 1/2 the integral between negative pi over 3 of cosine of u du. What's the antiderivative there? Sine of u. So we get 1/2 sine of u evaluated between pi over 3 and negative pi. One half sine of pi over 3 minus sine of negative pi. Well, Well, again, we get kind of lucky with one of these terms. Sine of pi or sine of negative pi, both are going to be 0. So get rid of that one. The other one we got to work with is the sine of pi over 3. You can play the same game that we did here, and realize that sine of pi over 3 is going to be root 3 over 2 again. Finally, we can put this together. I've got 1/2 times square root of 3 over 2 plus square root of 3 over 2. And the reason I didn't simplify that is because I'm going to take a little different approach to cleaning this up. Let's notice that I have a common factor here of square root of 3 over 2. And if I factor that out, I'm left with a 1/2 plus 1, which is 3/2. 3/2 times square root of 3 over 2, or 3 square roots of 3 over 4 for your final answer. All right, real showstopper there. All right, everyone's dancing in the aisles. Cool. You know, tricky. I know you guys don't like trig problems so much, but I mean, it is doable. Are there any specific questions on what we did here? Let's just double check our answer. And what I want to do is I want to do it numerically. I want to compare this answer numerically with what I get on my calculator. So from negative pi over 2 to pi over 6 of cosine of 2x. Make sure you put in the right parenthesis around that x, minus sine of x dx. And let's compare that to 3 times the square root of 3 over 4. They're looking pretty similar. So it's a good way, it's a real good way to double check your work, is to see that you get the same value for both of these. On a test, you know, there's various things I can do, but if I'm asking for an exact answer, this is what I want. Your calculator's not going to be able to find this. It will be able to give you that. So it can confirm it, it's not going to find it for you. Okay. Good enough for today? Okay. Let me give you some homework. For homework, try 1 through 29 and 37 through 41.